Sequences and series. So what is a sequence? If you were to count from 1 to 100, 1 to 10, or 1 to infinity, all these numbers go up by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They all go up by 1. So you know that there's a specific order in which they are arranged. Okay? So if we would say 2, 4, 6, 8, they go up by 2. 3, 6, 9, they go up by 3. And so on and so forth. So all of these are sequences and it can go up to infinity. But what if we added all these terms together? That is what we call a series. So a series can be listed in two ways. The first one is as a list, or the second one is in sigma form. So what is sigma? Sigma is the capital Greek letter and it looks like this. So all it means is the sum of, or addition. So you can see here I have created a little diagram that we're gonna go through in some detail. So the top number listed here, n, this is just an example, okay? N represents the upper limit of the ending value. R is equal to 1. That gives us, it represents our starting value or lower limit. So what we have here is a starting value and an ending value. So we know that our series will start at 1 and it will end at n. So if it were to go up by 1, well it does go up by 1. But if it were to go into a function, so let's say here, r is the function in this one. I want you to think of it as a function because what we're going to do is we're going to input the starting value, add 1 until we reach the ending value. In this case it's n. If you got confused just now, don't worry, we're going to go through some examples. But for now I want you to write this down and understand it. Understand what these letters mean, and remember, R in this case, it can be K, it can be Z, anything that's represent. I don't want you to remember R, but in K papers you will most likely see R, and as well as your IAs, you'll see R. At least that's what it was in my school. So the starting value always increases by 1 to the end value. We're going to go through some examples now. Okay, so the first one, the ending value is 11 and the starting value is 1. And we can see the function is r, so it's just that one value. So what we're going to do is say, okay, our starting value is 1, the ending is 11, and since the function is just r, all we have to do is put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And because of the sigma, or the summation sign, all we have to do is add them up. That's all we're going to do. So the second example now, it ends at 11, but it starts at 1. But now our function has changed to r squared. So what we have to do is we have to substitute our start to finish, substitute these values into the function, which is r squared. So we'd have 1 squared plus 2 squared all the way up to the upper limit, or the ending value, 11 squared. So at this point you should have a pretty good understanding, and we're gonna go on to number 3. So in my representation above, you can see our ending value was n. In this example it is n as well. So what we did here was we changed the function and we have our ending value as a variable, so it's n. So you would do the same thing. Our starting value is 1, and we would just substitute all the way up until the ending value, n plus 1, right there. Okay, so example number 4, the same exact thing, but all we did was have 3 as our ending value instead. And now, since we have all these values, we can simply simplify to get our answer. Okay, so this is very important. It's called standard results. So these are going to be given to you in most papers. They will be given to you, and you have to use them to evaluate something. But for now, we're going to learn them. Also, note this is super important. The starting value must be 1 for the results to be used. So r is equal to 1, r is equal to 1, and r is equal to 1. Note that in each and every one of these standard results, these 3 standard results that you have to memorize, or I believe they'd give it to you in the paper, but memorize it anyway. It's much faster if you just memorize it. So you can tell r is equal to 1, r is equal to 1, r is equal to 1. That's the first thing you have to notice before you go through any of this. So write it down. Just pause the video and write it down. So the first one is the sum of r. So it will be n, open brackets, n plus 1, close brackets, all that divided by 2. It can also be written as half n plus 1. They give it to, I don't want you to get confused, because in some papers they'll give it to you, and obviously you can tell, but I know when you look at some papers one time you'll be like, oh my god, what is that? But it's the same thing. And it's the same for r squared, 1 over 6 n plus 1 2n plus 1. Exactly. So r cubed, I have a special way of remembering this one. So all I did was square the terms of the result for the sum of r. So what I did is, since this is n plus 1 over 2, I would think of this as one term, and just square, and 2 squared is equal to 4, and that was that. So that's all I really did to remember it. So yeah, all you have to do is memorize this, and we're good. So let's look at an example using it. Okay, so the first example, number 1, has a starting value of 1. That's great. Okay, because now we know that's what we're looking for in all of them. Is the starting value 1? Yes. So let's go forward. Now we have an ending value of 11. The ending value doesn't matter. It can be anything. We don't need that right now. So we have the function that we're going to think of is r. So what we're going to look at, the formula we're going to look at is this one. Okay, so r is equal to 1 here, and our function here is r. So all we had to do was input this ending value, which in this case is 11, into this formula to get the result. So you simplify using your calculator or your brain, doesn't matter. So you would just have to substitute the value into the correct result. And to identify the correct result, you just look for r squared, or r cubed, and that's it. So let's do the same thing for r squared in example number 2. We have 2 as the end result, the upper limit, the ending value, and we look for the result. So we choose this one, of course, because it's r squared, and we input or substitute our ending value or upper limit into the formula to then get our result as 5. And it's easy like that. Now take a breath. We're gonna go through a special case. So I want you to look. What's the first thing I told you to look for when you're going to look at a summation question? Exactly. Is r, or your lower limit, equal to 1? Remember, it can't be, it's most likely going to be r, but it can be k, it can be anything else. So it's not. It's equal to 10 in this question, and we don't want that. So what are we going to do? We are going to split it into 2 summations, and we are going to subtract them. How am I going to do that, Rima? How am I going to do that? I'm going to show you. So you can see I wrote it here. All we do is say r is equal to 1, r is equal to 1, make sure we subtract them. In the first summation, the upper limit will remain the same. However, the second, what we're going to do is look at our initial, which is 10, our initial lower limit, which is 10, our starting value, and subtract it from 1, and that will be the second summation's ending value. So upper limit, our ending value. So here it will be 10 minus 1 is 9, and that's all we have to do. So take a moment and read what I wrote. We need to make both r's equal to 1, so we subtract a second summation. And remember, the most important thing is to get this initial lower limit subtracted by 1. So 10 minus 1 is 9, and we'll have our second summation's upper limit, which is 9. So recall, we can only use the result when the starting value is equal to 1. Exactly. So now that we have our starting values equal to 1 in both of our summations, we can use the standard results that we learned before. So if you got confused, we're going to do another example now, but I strongly suggest that you look over what I just said or write it down. It's really simple. Just look at this value, subtract it by 1, put it on the second one, and that's all you have to do. It's a pattern. You keep doing that, and for every single question that comes like that, and it's done. And now you can see, now that r is equal to 1, we can use the standard result. And our standard result for this one, we know is equal to n plus 1 over 2. So what we had to do is just substitute this, because remember now it's 9 and 51. We would just substitute it into this, the standard result, and get our answer. Great. Now our fourth example, it's the same special case, okay? Where r is equal to 11 this time, and we have r cubed. It doesn't matter. Just remember to include the same function as I did here, and we subtract. We subtracted from this one. We subtracted from. So we did the same thing. We look here, we subtract 1 from this lower limit. What? Yeah, 10. So 11 minus 1 is 10. And we put it at this here as this upper limit. And this becomes r is equal to 1, r is equal to 1. This stays the same as this. And then we use the standard results. That's all we had to do. The same one as the one above. And example number 3. So now we just say we substitute 21 and 10 into this result. Remember r cubed, the sum of r cubed when r is equal to 1, where the starting value is equal to 1, was n squared, n plus 1 all squared over 4. And that's how we just substituted the 21 and the 10 to get our answer. Okay, great. Now we're going to go through some summation laws. Okay, so now we are going to look at some summation laws. There are 3 laws that we have to know to be able to solve questions. And these go hand in hand with our 3 standard results that we learned before. The sum of r squared, and sum of r cubed. These we have to know together to be able to solve questions. So the first law includes the upper limit and a constant. So we can see all we do is multiply the upper limit by the constant to get our value. So in this example, there's 11 as our upper limit and 7 as our constant. To get our answer, we multiply them, and that's it. We get 77 as our answer. The second law is just as simple. All we do is pull out a constant. So I want you to think of, in this example, you see we have 7r. And all we do is we pull out the 7 and put it before the summation sign. So think of it as 7 by r. It'll be the same thing if you put 7 in brackets by r. That's all we're doing. Okay, we're just pulling out the constant. So now that we have the constant on the outside, we can use our standard result for r, because it's equal, our starting value is 1, and we can simplify it and then multiply it by 7 to get our answer. And that's all we had to do. Then our third and final law that we have to learn involves the addition of these two, and we can simply split it into 2 summations, and that's it. So in this case, in our example, there is the sum sign, and then we have in brackets r cubed plus r squared. All we did was split it into 2 different summations to make it easier. So now we can use both standard results, the one for r cubed and then the one for r squared, and simplify to get our result. Alright. Now we're going to look at questions. But before, I want you to remember that there are 3 summation laws and 3 standard results. We need to know these in order to solve this question, especially this one. And of course all the others, especially in past papers, although I only found one past paper which we'll look through. So the first question, 4 is our upper limit and 1 is our lower limit. That doesn't matter right now. What we do need to do is simplify this in order to evaluate. To simplify this, we need to use our laws, and to evaluate, we use our standard result. So we're going to use our first law listed here, which is law number 3 actually in our list. And what we're going to do is split up our summation. So we'll have our first one and our second one, and we simply use this law. Now r is equal to 1, so we can do this by using our this is a law and this is our result. So the first here will use the law, this will use our law, and this will use a result. So this will be 4 plus 1, 2 plus 1, all over 6. And then all we have to do is simplify. So this will be 30, I believe, and the answer would be 38, I think. Hopefully my mental math is good. So let's go through this again. All we did was split up the summation using this law. Then we use another law, which I think was our first law, to multiply the upper limit by our constant to get 4 by 2, which is 8. And this one, since r is equal to 1, we can use our standard result for the sum of r squared, and all we have to do is substitute 4 to get our value. So our answer, 38, hopefully I did that right. All you have to do is plug in this in a calculator and then you can do that. But mental math is always good sometimes. So now we're going to look at question 2, which says use the standard results for the sum of r and the sum of r squared to show this. And I did this question because I wanted to spend most of the time actually explaining and not writing. So we start the proof by saying required to prove and what was stated there. So required to prove this. So we start on the left hand side and we expand this bracket to get the sum of r squared and r, okay? And we use this law to then simplify it, to be able to use the standard results after. So we split it up by doing this. So we split it into 2 summations, like that. And now that we have the standard results for these, we're going to place them. So the standard results here. So this one is for r and this one is for r squared. And all I did now was with the 1 over 6 and the half was just write it in a different form, so it's easier for us to get to the third, because remember their form, they have the third in front. So at this point we just need to refer to the end result and work towards it. So we have 1 over 6 n plus 1, 2n plus 1 plus a half n plus n and n plus 1. So all we're going to do now is take out the common terms. So I know that 1 over 6 n plus 1 and n and n plus 1 is common here, and also we could take 1 over 6 out of a half to remain with 3. So this was our common term that we took out to remain with 2n plus 1 plus 3. So all we did now was simplify this to get 2n plus 4. Now we have 2n plus 4 and we have to take out the common term here to get 2n plus 2. And now we just multiply 1 over 6 by 2 to get a third, and that's it. QED, or your box, or hence proven. So yeah, all we really did there was use a couple laws in the beginning, like one law in the beginning and then our standard results, and then we had to just rearrange the variables and on all the terms to get what we wanted. So it was that simple. Okay, so what you'll notice is we actually did See Part 1 of 2008 Rest of World, or Rest of Region, so ROR. And now we're going to do Part 2, so pay attention to this one. This says, hence or otherwise evaluate this. So we notice that R is not equal to 1, it's equal to 31. So that's a special case. So we're going to apply what we learned before to do this one. So we say, okay, R is equal to 31. We need to split it into 2 and subtract. So 31 minus 1 is 30. And now, that's it. So now we know that we actually proved this before. So it's a third n by n plus 1 by n plus 2. So all we know is that r plus 1, where basically we have the evaluation already. All we need to do is substitute the values. So now that we have r is equal to 1 on both sides, we can simply substitute 50 and 30 into this and subtract them, because we already proved it before that this is equal to this, and that's what we had to do. So when we substitute the values for 50 and 30 into this, we get a result. So simplify this, you can just plug this in your calculator, get the answer, and that's it. So yeah, the topic isn't that hard. I think where the difficulty comes in is in the next topic, principle of mathematical induction, and we will deal with that next time. But yes, for now, learn your laws, learn your standard results, and you'll be great. Okay, thank you guys for watching. I hope you enjoyed.